Today, we're going to walk through the entire journey of a modern green energy project. We'll start with just an idea and end with a complex, powerful, and yes, profitable power plant.
So, have you ever looked at a huge solar farm and wondered, how on earth did that get there? How does an empty field of grass get transformed into a power source for thousands of people? Well, it's not magic. It's actually a fascinating mix of brilliant engineering, massive construction, and some seriously smart digital tech. Let's pull back the curtain and see exactly how it's done.
And to help us get our heads around this whole process, we're going to follow the work of WHT Energy. They're a company that's in the thick of it, handling every single stage of this journey and literally turning landscapes into hubs of sustainable power.
All right, Act 1. You know, every massive solar farm or wind park doesn't start with a shovel. It starts with a plan. This is the first, and you could argue the most critical phase of all, creating the blueprint.
Before anyone even thinks about installing a single panel, there is a mountain of groundwork to do. It all kicks off with identifying the perfect site. You know, a spot with just the right amount of sun or wind. Then you dive into feasibility studies and environmental assessments. You've got to answer the big questions. Is the land stable? What's the impact on local wildlife? Then comes the part everyone loves, the paperwork, navigating that whole maze of permits. And finally, you get to the financial modeling, where you figure out if the project is not just green, but actually profitable. Honestly, this stage right here is where a project lives or dies.
And when all that planning is done right, this is what you get. A real, tangible thing that can power communities for decades to come. So, okay, the blueprint is solid. It's time to actually build this thing.
And that brings us to Act 2, the build. The blueprint's approved, so it's time to break ground. This is where the vision starts to become a physical reality.
Now, in the industry, this whole phase is called EPC. That stands for Engineering, Procurement, and Construction. You can think of it as the complete package. It starts with the engineers who custom design the entire system, making sure it's perfect for that specific site. Then the procurement team basically goes on a global shopping spree, sourcing the best panels, turbines, and batteries from all over the world. And finally, the construction crews get to work, bringing that blueprint to life and turning an empty field into a high-tech power station.
So building all that hardware, that's really only half the battle. To make a modern power plant really work, especially with renewables like sun and wind that come and go, you need a powerful digital brain.
And this brings us to what is probably the single biggest challenge for renewables, grid stability. See, the grid, it needs a perfectly consistent flow of energy. Think of it like a constant, steady hum. But the sun sets, and sometimes the wind stops blowing. That creates dips and spikes that can throw the whole system off balance. So, how do you solve that problem?
The solution, and what's so cool about this, is a combination of muscle and brains. On one side, you have the physical hardware, these huge battery storage systems that act like a giant energy savings account. And on the other side, you have the software. That's the brain that decides second by second when to store energy, when to release it, and how to keep that grid humming along perfectly.
And this tech is incredibly efficient. We're talking 95% round-trip efficiency. That just means for every 100 kilowatt hours of energy you pump into the battery, you get 95 of them back out. Almost no energy gets lost. It's a super effective way to bottle up sunshine for a rainy day.
And these things are built to last. They're not short-term fixes. These battery systems have lifespans of over 20 years. That kind of durability is absolutely essential for making the long-term finances of a project like this work.
The software platform, like this one from WHT, is basically the central nervous system of the entire operation. It's not just balancing the grid, it's running predictive maintenance to fix things before they break, it's analyzing financial performance, and it's making sure the whole plant is following all the complex regulations. It is total operational control, all from a screen.
So, we've got a fully built, digitally controlled power plant. It's running smoothly. But how does it actually make money? How do you get a return on that massive initial investment? Let's talk about the payoff. Well, does this whole integrated approach actually work out in the real world? Numbers like this suggest, yeah, it really does. Seeing 15% market share growth tells you that more and more customers are buying into this model. It proves that it's not just good for the environment, it's a powerful and competitive business strategy.
And in the energy business, you know what's king? Reliability. A 98% client satisfaction rating, that isn't just a feel-good number. It translates directly into long-term contracts and builds a reputation that attracts new business. That's how you build a profitable operation that lasts. And the money doesn't just come from one single source, it's actually a pretty diverse portfolio. Some of the energy gets sold on these fast-paced markets, traded almost minute by minute. The plant also gets paid just for being on standby, providing those critical stability services to the grid we talked about. For steady, predictable income, you have long-term contracts called PPAs. And then on top of all that, you can sell things like green certificates and carbon credits. It's a whole ecosystem of revenue.
And you can see the real-world impact right here. When you get a quote like this from a major Fortune 500 company, it shows that when all these pieces, the development, the construction, and the digital operation, when they all come together seamlessly, the results can be pretty extraordinary.
Okay, so we've seen the whole process from blueprints to power plants as it works today. But this technology is moving at an incredible pace. So what's next? Where is all this headed?
Well, the roadmap for just the next few years is pretty mind-blowing. We're talking about next-generation materials for solar cells that are way more efficient. We're looking at full AI integration, making these plants smarter, and basically able to run themselves. Then there's the rise of green hydrogen as another way to store clean energy, and virtual power plants that can link thousands of different energy sources together into one giant, coordinated network.
And really, this image captures the ultimate goal. It's not just about building individual power plants anymore. The future is a completely interconnected, intelligent, and sustainable energy ecosystem that powers our entire world.
So, the technology is here, the blueprints exist. Companies like WHT are out there right now actively building this future. But a shift this big, it impacts everything: our jobs, our landscapes, our entire economy. The system is being built. But the bigger question is, are we as a society ready for all the changes it's going to bring?